Earlier this month, astronomers recorded a brief but unmistakable flash of light on the Moon. The result of a small space object striking the lunar surface at extreme speed. What makes this event notable is that it was captured live by a ground-based telescope, offering a rare real-time look at a lunar impact. Early analysis suggests the collision may be linked to debris from the Gemini meteor shower, a well-known annual meteor stream. In this video, we will break down what was observed, why it matters scientifically, and what it tells us about ongoing activity around the Moon. Let's get started. The impact occurred on December 12, 2025 at 309 UTC. At that moment, a small but distinct flash appeared on the Moon's surface, lasting less than a second. The event was detected during routine lunar monitoring using a robotic telescope capable of recording rapid transient phenomena. What sets this observation apart is that the flash was seen as it happened. Most lunar impact flashes are identified later, either by automated software or by reviewing recorded footage frame by frame. In this case, the observer noticed the flash live on screen, something even experienced lunar observers may never witness during their careers. The timing and location of the impact were favorable for detection. It occurred on the unilluminated portion of the Moon during the new moon phase when the absence of sunlight allows brief flashes to stand out against the dark lunar surface. Impacts on the sunlit portion of the Moon are effectively invisible from Earth due to overwhelming reflected light. Initial analysis suggests the object responsible was very small, likely only a few centimeters across. Despite its size, it was traveling at extremely high speed on the order of tens of kilometers per second. At such velocities, even a tiny object carries enough energy to produce a detectable flash when it collides with the Moon. Based on the telescope's orientation and frame-by-frame analysis, astronomers estimate the impact occurred slightly northeast of the Langris crater, a prominent feature on the Moon's near side. Determining an exact location takes time as researchers must account for viewing geometry, timing precision, and potential instrumental effects. From an observational standpoint, this detection is notable. It represents the first confirmed lunar impact flash recorded from Ireland and only the second documented from the British Isles. Given the Moon's size and the fleeting nature of these flashes, such observations remain difficult to capture from Earth. Although the impact itself was small, events like this are scientifically valuable. Lunar impact flashes provide direct evidence of how frequently small objects collide with the Moon. Information that is difficult to obtain through other means. Unlike Earth, the Moon lacks an atmosphere to slow or destroy incoming debris. Objects of all sizes strike the lunar surface directly, preserving the physics of the collision. When a meteoroid impacts the Moon at high speed, its kinetic energy is rapidly converted into heat and light, producing a short-lived optical flash. By measuring the brightness and duration of such flashes, scientists can estimate the energy involved and infer properties of the impacting object, including its approximate size and velocity. When combined across many observations, these data help refine models of the small object population in near-Earth space. The timing of this impact is particularly relevant. It occurred during the active window of the Geminid meteor shower, which runs from early to mid-December each year. The Geminids are one of the most intense and reliable annual meteor showers known for their fast and bright meteors. What makes the Geminids unusual is their origin. Rather than coming from a traditional icy comet, the shower is linked to a rocky object known as 3200 Fathun. This object behaves more like an asteroid, but it sheds debris as it passes close to the Sun. Over time, this debris forms a dense stream along its orbit. When Earth passes through this stream, we see Gemini meteors burning up in the atmosphere. However, Earth is not the only body intersecting this debris field. The Moon regularly passes through the same region of space, making it vulnerable to impacts from the same population of particles. preliminary estimates place the impact speed at around 35 km per second, which is consistent with typical Gemini velocities. While this does not conclusively prove the object originated from the Gemini stream, the timing and speed strongly support that interpretation. Events like this help validate long-standing theoretical predictions. They demonstrate that meteor streams can produce detectable impacts on the Moon and that these impacts occur with measurable frequency over long time scales. Countless similar collisions have contributed to the Moon's heavily cratered surface. Importantly, this observation also helps constrain the lower end of the meteoroid size distribution. Large impacts are rare and Wells-tied, but small impacts are far more common and much harder to detect. Each confirmed flash improves our understanding of how often these small but energetic collisions occur. Beyond their scientific value, lunar impact observations have practical implications, particularly as interest in sustained lunar activity increases. Future missions plan to establish long-term infrastructure on the Moon, including habitats, scientific instruments, and communication systems. Even small impacts can pose cumulative risks to exposed equipment. Understanding how often these impacts occur and with what energies is essential for designing effective protective strategies. This event also highlights the importance of continuous lunar monitoring. Advances in imaging technology, automated detection software, and coordinated observing networks are making it increasingly feasible to detect impact flashes in real time. What was once a rare observational success may become more routine as these systems improve. There is also the possibility of follow-up observations from lunar orbit. In some cases, high-resolution images from orbiting spacecraft can reveal fresh impact craters corresponding to observed flashes. While many impacts are too small to leave easily detectable craters, even the absence of a visible crater helps refine size estimates. From a scientific perspective, lunar impacts serve as natural experiments. Each collision excavates material from beneath the surface, briefly exposing it to the space environment. Studying these processes contributes to a better understanding of how the lunar surface evolves over time. On a broader scale, events like this illustrate the dynamic nature of the Earth-Moon system. The Moon is constantly interacting with its surroundings, responding to the same streams of debris that produce meteor showers on Earth. As monitoring efforts continue, astronomers may increasingly be able to link individual lunar impacts to specific meteor streams. This would allow more precise mapping of debris populations and their interactions with planetary bodies. In the longer term, systematic lunar impact monitoring may also contribute to planetary defense research. While small objects pose little direct threat to Earth, understanding the distribution and behavior of near-Earth debris is a key component of assessing larger impact risks. This brief flash on the Moon was a direct real-time glimpse of an otherwise invisible process. It confirms that the Moon remains actively shaped by ongoing impacts from debris moving through the inner solar system. As monitoring improves, events like this will shift from rare surprises to valuable scientific data.